Hello everyone, this is Yogesh from Shri Venkateswara College of Engineering, Electronics and Communication Department. Now I am going to explain a sum from the subject Circuits and Controls. Topic numerical based on superposition theorem, Thevenin's theorem. The Wheatstone bridge in the circuit shown in figure 4.96 is balanced when R2 is equals to 1200 ohms. If the galvanometer has a resistance of 30 ohms, how much current will be detected by it when the bridge is unbalanced by setting R2 to 1204 ohms? Please watch out the figure 4.96. There are two resistors 900 ohms and 600 ohms and 120 volts, and the other two resistors R2 is equals to 1200 ohms and R4 is equals to 800 ohms, and galvanometer G, and the 2 points A and B. To find VOC, we are interested in the galvanometer current. Hence, it is removed for the circuit figure 4.96 to find VOC, and we get the circuit shown in the figure 4.97. I is equals to 120 divided by 900 plus 600, that is equals to 120 by 1500 amperes. I2 is equals to 120 by 1204 plus 800, that is equals to 120 by 2004 amperes. Applying KVL clockwise along the path 1204 ohms, B minus A is equals to 900 ohms. We get 1204 I2 minus VI minus 900 I1 is equals to 0. V1 is equals to 1204 I2 minus 900 I1. 1204 into 120 by 2004 minus 900 into 120 by 1500. That is equals to, by calculation, we get 95.8 MV millivolts. After finding out, we can get to know the value of V1, VOC. To find R1, deactivate all the independent sources and look into the terminals A and B to determine the Thevenin's resistance as shown in the figure 4.98. Here 900 ohms R ohms, let us interchange the circuit diagram, and then we get this second diagram. R1 is equals to RAB is equals to 600 parallel to 900 plus 800 parallel to 1204. As we know that resistors, parallel resistors, the equation is given by R1 into R2 by R1 plus R2. We'll substitute the formula and we'll get this equation, and 900 into 600 by 1500 plus 1204 into 800 by 2004. That by calculation we get 840.64 ohms. Hence, Thevenin's equivalent circuit consists of 95.8 millivolt source in series with 840.64 ohm resistor. If we connect 30 ohm resistor galvanometer resistance to this equivalent network, we obtain the circuit shown in the figure 4.99. Ig is equals to 9.58 into 10 power minus 3 by 840.64 plus 30 ohms. That is equals to 110.03 microampere. Let's go for superposition theorem. For the network shown in the figure, apply superposition theorem and find the current I. In this diagram, we have to find the current I. Open the 5A current source and retain the voltage source. The resulting network is shown in the figure 4.280. The impedance as seen from the voltage sources Z is equals to 4 minus J2 plus 8 plus J10 minus J2 by 8 plus J8 is equals to, by calculation we get 6.02 angle minus 45 degree ohms. Hence IA is equals to J20 by Z, that is equals to 3.28 angle 138 degree amperes. Next, short the voltage source and retain the current source. The resulting network is as shown in the figure 4.289. Here I3 is equals to 5 ampere. Applying KVL for mesh 1 and mesh 2, we get 8 I1 plus I1 minus 5 J10 plus I1 minus I2 into minus J2 is equals to I2 minus I1 into minus J2 plus I2 minus 5 minus into minus J2 plus 4I2. Simplifying, we get 8 plus J8 I1 plus J2 I2 is equals to J50, and J2 I1 plus 4 minus J4 of I2 is equals to IJ10. Solving, we get IB is equals to I2 is equals to determinant of 8 plus J8 J50 J2 minus J10 divided by determinant of 8 plus J8, J2, J2, 4 minus J4. That, and by calculations we get 2.897 angle of minus 23.96 degree ampere. Since IA and IB are following the opposite directions, we get IA minus IB is equals to 6.121 angle of 144.78 degree amperes. Thank you everyone. Please like and watch and subscribe my channel.